let's finish off the example problem, this coordinate geometry question. I do need you to make a change very quickly to the coordinates in your notes. I did make an error, and as I was doing this, I discovered the error, so now this is why it's in a second video. I am telling you that we have an isosceles trapezoid, and the vertices are Q, U, A, and D at -2, 6, 3, 8. This is what you need to change. A is at -8, -3, and D is at -6, 2. And what we want to do is show that the diagonals are congruent. So to complete this problem, we need to use the distance formula. And recall that the distance formula is based on the Pythagorean theorem, which is when we take the difference of the x coordinates and square them, and add that to the difference of the y coordinates squared, and then we take the square root of that whole thing. You can punch this into your calculator as one full expression. You just have to be very careful about using your parentheses appropriately, because remember, the calculator will follow the order of operations, and if you don't have a parenthesis on a negative and you're trying to square it, it won't return you the correct value unless you include that. I'm going to go ahead and graph these vertices really quickly, even though you don't need to, because the order I gave this to you in, you're going to go ahead and be able to figure out that your diagonals are QA and UD, because those are non-consecutive vertices, and it's just a quadrilateral. But I do think a picture might help us a little bit. And so I'm going to, Q is at -2, 6. U is at 3, 8. A is at -8, -3. So I'm going to go from Q to U to A. I know this does not look like a trapezoid yet, but just wait. And then D is at -6, 2. And there it is. And now it does look like a trapezoid. If we wanted to, we could find the slopes of these sides and show that they are, in fact, the same. But again, what we really want to do is show that the diagonals are congruent. So we're going to be taking a peek at this segment here and this segment here. So I went ahead and started this for us. Again, using our distance formula. If my x1 or my x2, it doesn't really matter here, is -2. So if I do -2 minus -8 and I square that, and then I go back and I do 6 minus -3. Remember, this is going to be a -3. This becomes 6 squared and 9 squared. And then 36 plus 81 is 117. I'm just going to leave that as a radical, 117. That was the length of QA. Now I'm going to move on, to the length of UD, which is 3 minus -6 for my x's, and I'm going to square that, plus 8 minus 2 squared for my y's. Again, you could just punch this whole thing into your calculator and you will end up with the correct answer. Just be careful of these parentheses. Once again, I'm going to get 9 squared plus 6 squared. That's usually what you kind of see in these types of problems. And that will, again, bring us to a distance of root 117. And there we have it. We were able to show that the diagonals of an isosceles triangle, isosceles trapezoid, are congruent, and we use coordinate geometry to do that. Great job.